All right, all right. Streaming at. Oh, you can't even see my face. Nice. All right, all right. Streaming at. Let's see. Decrease this. And yeah, that should be good. Yeah, I think we're good. Cool. So we're just gonna go back into this. I'm gonna be using OBS now, not from Restream because I don't know, it's kind of laggy, and I didn't really like that. But yeah, so I realized that this actually slides for these problems, and depending on like the number of weeks that you put in. So I think the original one was blind 75, right? And it was like, oh, okay, you write 75 questions. That's it. Out of this one, I've almost done it. Almost done all of them. I have like a couple easies in here, but for the most part, there's like these hards and like some easies, and then like that's it, basically it. I'd rather just keep solving problems though. Like, why stop? Why stop solving problems? Let's keep going. So I can crank this thing down to like 169, and then just try to solve all these. And I like that idea. Not sure. I'm most likely not going to do 40 hours a week. It'll probably be, half of that. And, in like 8 weeks, something like that. And I'll just go week by week. So like this one will be week 3. I'll like do all these. And yeah, that'll be it. Another thing too is I want to open up Illustrator so I can do like some drawings. I don't know. I hope this doesn't like destroy this like little MacBook I'm on. It should be fine though. But I also want to record like just a couple drawings, just going through like some of the problems that I've solved, so we can all learn. I can practice going over problems that I've solved before to make sure that I'm not like just hardcore memorizing them. Just be a big win. Okay, it's opening. Yeah, I've been having I was getting a little worried about just being able to stream because yesterday I was going to, and what do you even call it? I have like a display link hooked up, and I think it's just dying now. Like one of the USB ports just stopped working yesterday, and at the same time, the monitor crashes like maybe once an hour. So it's probably gonna crash today, and then like this thing is just gonna shut off, and then I have to like maybe set it up, or maybe I don't even know, because like I need the docking station, or I need to get a new one. Anyways, okay, so all that's said, let's go into like one of the problems, I guess. Can go over sort colors, subsets. Unique paths I've already done. Did container with most water, like I explained it. Word search I did yesterday, I think, but I didn't explain it. And I have not done the daily. But we're still going strong. We're going strong. Kth's smallest element in a BST. Minimum height trees. Set this match. Could do minimum height trees too. And go over how this is coded. Okay. So that'll be fine. And I think I can just drag this one over to here. And just get like some full on. Now I need to create a new paper sheet, something a little bit bigger for drawing. Perfect. Here we go. Here we go. Okay, so sort colors. So given an array of objects colored red, white, or blue, sort them in place so that the object of the same colors are adjacent. And the integers will represent the colors, right? So we're kind of wanting to sort, and we have 0, 1, and 2. Now, there's a sorting function that's called counting sort, where you will actually just like map everything, and you'll count like the number of occurrences. So you say like, oh, well, there's like 5 ones or whatever. There's like 5 zeros, and there's like, 3 ones. And then you just iterate over the array again. And so you say like, okay, we're going to fill the first one with this money, fill the first one with the next one with this many, right, with ones. And this works as a sorting function. It's like O of K, right? O of K being like the number of digits. And this is how counting sort. It works, but in this one they want it in place, right? So kind of doesn't work for this problem. And actually, I mean, it does work for this one. It just uses extra space, right? So it's the follow-up here. This is the hard part of the problem. This would be like a Leetcode easy, I think, but just doing it that way. But so how do we do it in one pass? So doing this in one pass involves just swapping. So like we have like a 1 pointer, right? We'll have like a 1 pointer. We'll have a 2 pointer. We'll have a 0 pointer. Oh, a 0 pointer, my bad. And a 2 pointer. And we'll set the 2 pointer to we'll set the 2 pointer to be at the end, right? Because that's where we're going to be placing them. If we see a 2, then we just swap it and put this 2 in the back. And whatever was in the back isn't a 2, so we're going to put it into the front. And the same thing with a 0. Every time we see a 0, we say like, oh, well, we found the 0 right here, right? Or somewhere, right? Like we found a 0 in the middle. Well, let's put it back in the front. And then we just change the pointer. So like the 0 pointer is going to get incremented and be like at any place. To draw this out, maybe, because this is, probably better visually, right? But like we have like a 2, a 0, and a 1. What we can do is we can say, oh, well, our 0 pointer is going to be here. Our 2 pointer is going to be here. Oh, well, this is a 2, so let's swap them. Let's go 0 with 2. And now let's move the 2 pointer. And we still have the 0 pointer here. And then we'll check, okay, is this 1 a 2? No, it's not? Okay, cool. So then as we're going to go, we're going to keep track of these pointers, and we're just going to keep iterating through the array. So we're going to say, okay, well, then what's next? Okay, so we have the 0. Okay, well, now the 0 is going to get swapped. So we swap it. And then we put the 2, so we have this one here, and then this one here. And we can kind of break out now and stop iterating because we know that, like, we're already at our boundaries. The 2 boundaries here, the 0 boundaries like here, and this thing is now sorted. So that's the general basis of this algorithm, and then like the code for this looks like. And the code for this looks like having a 0 pointer, having a 2 pointer, having a function to swap, right? Just checking, okay, is it a 0? Is the 0 pointer equal, not equal to I? And then we just swap them. And if it's a 2, then we swap them and then decrement the 2-pointer. And then we just do while I is less than the 2-pointer. And yeah, that's it. So that's that one. Subsets. Subset is just like straight, like just backtracking. It's like, do you know how to do backtracking? So like, we'll have like some array and it's like 1, 2, 3, right? And we want to generate all subsets for 1, 2, 3. So what we're going to do is we're going to have like just like an empty bracket, because that's also a subset. And then we're going to go break out into the 1, the 2, the 3. And at every step, we're just going through the array and adding in like whatever we're taking essentially, right? So like at every decision, we're just going to say, okay, well, let's grab the 1. And then we jump and then we're like, okay, well, let's grab the 2. And every decision tree is kind of like breaking out like this. Again, if you don't understand backtracking, then this is probably impossible. But if you do understand it, then this is like pretty straightforward. We're just grabbing like the next one. The 2 is going to grab like the 3. The 3 is just going to be left alone. And at every step we're saving. So then we just like save, right? So I don't know how I would represent a save, like maybe like a star, but we're saving at every step. And we're deciding to grab. So we just keep track of whatever position we're in, whatever like the I position that we're in. And then DFSing and just calling it. And this one's gonna be like 1, 2, 3. And this one, right? This code is just gonna look, it's not that much, but just checking, okay, are we out of bounds? Let's add it, let's save it, which you would see in that star, and then just let's go from I all the way to nums. Let's increment that position and keep going. Okay, and another classic one. So this one is very similar to number of islands, and what we're going to be doing here is that we have like some grid of characters. And what's this? We want to find out if the word exists. So like we'll have like, okay, here's some characters and we have like the word here. And we just want to see, okay, is this thing in here? Is C in here? SEE, right? This one is just the standard like breadth first search that we'll see like all the time. And I mentioned it, like this is like so critical, but like, yeah, I wish I could just explain like how important it is, but I'll just have to keep repeating myself. But like, it's very important to know this algorithm, despite of like how stupid you may think Leetcode is if you've never heard of a binary search or whatever. But we'll have A, B, C, E. We'll have A, B. I actually don't even know if it's worth it to draw all of this, but let's not draw all of this because I think it takes time. But like, let's say we just have like some grid, right? Very similar to spiral matrix, and again, all the other problems is we're just gonna have like a thing where we say like, oh well, do you equal like let's say the word is A. Do you equal A? No? Okay, cool. Well, you don't matter anymore, right? Like, not that you don't matter, but not that it doesn't matter, but okay, this one doesn't, so we're gonna check every single one for A. No, you're not A. Okay, oh, you are A. Okay, well, let's say the word is AB. So like, okay, oh, you are A. That's cool. Well, now let's go inside and check, do your neighbors. Is your left part B? Is your right B? Is this one B? Is this one B? Do that, and then we'll just check and see, okay, well, hey, if it is B, then we've reached the end of our word. If we've reached the end of the word, then that means that we know this one is a word and we can just return true. There's a lot, playing around with this, but like, that's why it's so critical to know breadth first search, because you just know that like you add it into a stack, right? Like you have like some stack, you have A, like B or whatever, all the way up until like whatever the length of the word is. And then you just go through, cross it, mark it as seen so that we don't go back whenever we're at the B, like we're not considering this one at all, and enter it into like some infinite loop. Make sure that we don't go out of bounds, right? But we just keep going until we reach the end of our stack. So this one is, oops, my bad. This one code looks like this. It is a little bit lengthier, and it can get even more lengthier if you're not using a directions array. You would have 4 more if statements, but yeah, that is this problem. And I'll leave it at that. And then we have minimum trees. So this one was like really annoying actually, and I had never seen something like this before, but like we have like some graph. Let's delete all this. It's like this one was annoying, but like we have like some graph. It's like 0, like 1. 0, 1, like 2. We have like some nodes that are just generally there, and we have like all their connections. This one's just like one understanding, I guess, implicitly that like getting the minimum height of just like some list of like graphs that are randomly assorted. Like, you know, it's this getting to the solution for this one is very difficult because you have some graph that has like some vertices, and those vertices are connected in some kind of way. And we want to return what should be the root in order to minimize the height, right? Which sounds complicated, but at the end of it is just like backtracking from the leaves until like the central node, and like figuring out which one is least likely to be a leaf, and then just like returning it. So like we have all these leaves, and we're like, oh well, you're a leaf, so then we exit out, we delete it. You're a leaf, okay, we delete it. You're a leaf, we delete it, and then we add all of the other leaves as we step. So in this case, you know, we delete 0, 1, and 2, and 5, and then we're like, oh well, we only have 2 left now, so like it's chill. If there were 3 left, then we would, you know, you basically just find the leaves at every time. But like this one, there's only, these leaves are connected to each other. So they can either or, like you basically just have at max like 2 possible answers for this. But like, yeah, it's just like a super weird problem. But at its core, like the solution is just delete, 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 leave, delete, leave, which is called topological sort. And then if it's less than 2, return it. If it's less than or equal to 2, return it. If it's not, then keep deleting leaves until it is. All right. So those are the problems I solved for blind 75, and we're gonna keep going. I don't think there's anything else. I went over like spiral matrix. I put this on my YouTube channel. And cool. So we'll just keep going. Oh yeah, and construct a binary tree from pre-order and in order. Actually, I did this one. I looked at it, but I never solved it. This one is so annoying. It is so annoying. This problem is you have like some list of pre-orders, some list of in orders, and let's actually draw this out too. So what is it? 3, 9, 20, 3, 9, 20, 15, 7. This problem is that you have like all the pre-order nodes of this. So you're like, okay, 3, 9, 20, 15, 7. And at the same time, you have the in order. And so you want to like generate, what does the tree actually look like from this? Like from like the integers. This one's hard because you have to know that like, okay, when you in order, like you're kind of splitting it into a non-in order and then like subtrees basically. So you start with 3 and then you start at 3 and you would find 3 on here and then you would break it. So like this is all of trees left children. This is all of 3's right children. And then you jump inside again. So we're going to say 9, right? It's a recursive backtracking that we're also like keeping track of indexes of where we're at into here and splitting this into subtrees. So here we're like, okay, well 9 has no left subtree, no children. And then all of these, I believe, are the right subchildren. And so then I think you just do that, I think. Or no, it's not, because we already have the right subchildren and they're in the 3. So I think this one just has nothing, because there's nothing to the left of it. And we've already done everything that's to the right of it. And so here we go again for 20, and we're like, okay, 20. You're going to go here from here, and like here to here is like some kind of boundary thing that's happening. And I don't even fully understand this one. That's why it's still like unmarked, but it's just some weird thing where you iterate through, go through every node, and for every node you're like looking up, okay, 9, where's 9 on here? It's here. Okay, all of the left is there, all the right is right. 20, where is it? It's here. Okay, all the left is here, all the right. This is going on and on. I've only been talking for like 20 minutes and it feels like so crazy. Like I have it feels like I'm talking for a lot longer. Whew, boy. Anyways, how would I get like the subtree part of this? I can understand looping through, right? Every time you DFS, you just increment. And I can understand passing in the boundaries. So in this case, like we're at a 3. So we know we're at position 1. So we know the boundary is like 0 to 1. But then how does a 9 know that? So that's where it gets weird. And I might just have to just look at the solution, because I've spent a lot of time on this problem, but like this might even have been like me attempting it. I don't even know. I think this is so ugly. I like Leetcode's solution because it was like pretty fast. I think it was like 5 lines of code. Let's take a look at it. Again, I'm not going to spend too much time on this because I already spent like time trying to understand how to do it. It was just ridiculous. Right, so we have the mid, and then it's just going to be like whatever is the at 0. That can't be right, no? Okay, I guess he's splicing it every time. I don't like splicing it. That seems suboptimal, but if it gets it, then yeah, like if you abstract it, it's fine, right? But sure, because I think this is probably the problem, so it probably makes sense. But like, so we're just gonna start. We're gonna like, okay, if it's not, then like if it's out of bounds, then do nothing. It's not valid. The root is just like whatever the node is that we're at. The mid is going to be, the midpoint is going to be like where is that located on the in order list. And then its left child is going to be like all of like the left subarray. So 1 to mid plus 1, and then mid all the way up to mid, right? Everything that's like to that left of that. So here it would be, and then here if we're at 20. And then we get 15 on the left, 15 on the right. Here is 1 to mid plus 1. That's, wait, hold on. 3, 3. What's this? 1. God, I hate doing this. 1 mid plus 1 to in order, and then you mid. Oh God. Oh, this is the pre-order list. So this is the pre-order, and then this is the in-order list. And the in-order list is everything that's to the left to mid. So when we go here, we'll put in 9. And then we'll put in that's so weird. 1 to mid plus 1. So we'll find mid. Mid is, because it's weird because mid is in the in order part, which is 1 for like 3. And then we're saying that like the pre-order is 1 to 2. Why? And then we're saying, okay, everything that's until mid. I get this part though, everything until mid. I get that part. But like, why only increment from 1 to mid plus 1? And then for the right, we're doing like mid plus 1 till the end. So doing mid plus 1 here until the end of the array. Yeah, I don't understand it. It's like so crazy. Yeah, slicing. Okay, I still don't understand it. Why is it 1 to mid plus 1? I don't know. And even if I watch the video, I don't even think I would understand it. Because I have watched the video. There's just like some problems that are just so crazy, like splitting trees is like, that's such a crazy like algorithm. Of splitting in order trees like based off of like their traversals. That's so weird. Oh, and I didn't do these because these were all DP, and I still don't want to do DP yet. So I'm gonna try to work through these. And I feel like this one's a DP too, but I'm not sure how many I'll be able to solve today, but we'll see. Yeah, the subarray with the largest product. I feel like this is DP because it's like subarrays. Okay. Yeah, I think it was DP, like subarrays. I need to do DP, but just not now. So I'm going to do Pacific Atlantic, and then I'll do nth node. And not even sure what to do with this one. in order. Index pop. I like this one because it's popping it, right? Like it's not just keeping it, but it actually removes it. And then this one, it gets the index of it. And then we get the root. Or we create a tree node. And then we make the left equal to the pre-order, right? So like we're popping it every time. We're not doing like that super weird thing that like he does in his video where it's like, oh, we're just going to slice it and do mid and then mid plus one. Like I don't understand that, but I can understand going through step by step in the pre-orders and then popping and then going, right? Like move in the pre-order, we traverse like a pre-order, and we pop it, create the root, and then we take everything that's on the left side and then everything that's after on that right side, and we kind of like build trees off of those. Oh wait, shoot, I missed this. I missed your message, my bad. So I was typing. What's up, no condom Chris? Grinding all 169. That's what I like to see. Nice product placement. Wait, what's product placement? Oh, because of the books. Yeah, no, I think I want something that like have the background like look better, but I don't have any posters. So I just have like these two books. I think that's basically it. It's either these books, or it's gonna be a plant. That's it. I love both these books, and I'm like super into like finance stuff. So yeah, that's why. Wait, how's it going? How's it going, Chris? How's the Leetcode? I did the contest. Can't wait to get rich through Amazon, FBA, and crypto mining. Yeah, I don't know if man always delivers. Yeah, I'm gonna bring out my new crypto coin, and we're all gonna be millionaires. And then I'll pull it out like everybody else, like all the crypto scammers. Did I enjoy it? I mean, I did well on it. The problems were like easy, right? Like I think it was just like breadth first search and then like some number thing. So I think I did well. That's it. I did the one in the morning too, but I just couldn't even do that one. I think it was like dynamic programming, so I just couldn't do it. But this one, yeah, we solved. And I got pretty well on that. Question Fury is very, very hard. Don't worry about that one. Yeah, I saw it was like 10% accepted, I think. Like even now, it's still like 10% acceptance rate. Is it going to give me a nope? If I do slash problems. Yeah, acceptance was 10 to the 5th. So this said, like for this one, I was thinking that like it was like I thought it was like a math like distance formula one where like that was the only solution that I could think of, where like you have like, okay, these are all chain linked together, right? So like the distance between one and the other ones is like 3 or like 2 right here, but there's a link in the middle. So like you can consider the distance of that other link. So I thought it was like some math problem where you're calculating what's the closest distance. You consider two distances. One is like the normal distance, and then the other one is like, can you jump into like this like portal basically and get that distance? Yeah. I haven't even looked at any of the solutions people posted, but yeah, I'm really curious to see how my rating goes up though. But you have that one. I applied to TikTok too, and one of the recruiters said maybe they'll interview me, I guess. I don't even know what that means, but like they're just like, hey, maybe. So that's where we're at. Okay, I think but yeah, I think this one's definitely way more intuitive. So you get like the midpoint plus 1 to the end, and then everything that's to the left of it. And you just check, okay, if it's invalid, then if it's an invalid index, then we're good. I really shouldn't, but I don't know, actually. I'll type it from memory, I guess. Just to like try to build like some form. So like if in order, we'll take out the root. Midpoint of node, we'll do like pre-order or like in order dot index pre-order dot pop for that one, and then what is it? We create like a node. Based on, is it in order? Midpoint of the node. And then what we're gonna do is new, or what, root, or no, nude node dot left is whatever is returned when we build another tree based off the pre-order and in order, but we're only going on the left side. And then we'll do the same thing, but only go on the right side. And then we'll actually return the node. And then you just plus 1 to the end. And then self.build tree. Is not in the list. That was it, just 3. Maybe I messed up on like one of these. This plus 1. Maybe. No, I didn't. Oh, you have to pop at 0. That's so weird. Okay. So you're popping from the front at every time. Cool. Yeah, this makes way more sense. Makes way more sense. I feel more comfortable about that. Just doing it that way. Just get the midpoint and go through every step every single time. And then I guess we'll see this one in a couple days to see if I remember it or not. I need to actually write down all the problems that I struggle with so that I know to go back to them. So what we'll do is we're gonna go here and then just copy and paste the name and then like put this one in like a list in like my notes. Also, Chris, how'd you do in the contest? I don't know if you're still here, but I'm curious, like what your scores, I guess, look like. Because you've been doing Leetcode for a while too. I want to know how Midnight Simon did, but I guess I'll have to wait. I don't think he put it on his stream. What do I do with... What is this? No. What is this? Leetcode. Let's see, problems. Okay, I'll put something in. All right, cool. Pacific Atlantic water flow. So we have some island. And the water flows. Pacific touches the top and left. The right and bottom partitioned. Height above sea level. Island receives a lot of rain, and the rainwater can flow to neighboring cells if the height is less than or equal to the cell's height. So here, pretty small constraints, I think. At a 200 by 200 grid. So do we iterate over every single one and then just like check if it goes back, or do we see, I guess the brute force way would be that you just check and see, okay, hey, does this one reach both oceans? And then you try to go there and it doesn't, and then you do here and it can't. Here it can't, right? Here it can, here it can. Here it can because it touches and then touches. There's probably like some DP thing too, where like you say like this one already can touch, so we can check like if it already does touch, I guess in the future. Don't know if, again, I don't think it's necessary, but it would be a slight change though. Just have a DP array, I guess. Here touches because it touches one that can go, and it also is touching the Atlantic, and it can touch the Pacific. Yeah, I think it's just better just simulate just over every single one, and we'll just check if like the other one is like less than or equal to, and then return if it can. Return true if like it touches both. And then the process of touching both would just be I guess just being on this part. You just have to be like being on this edge here. or not being like these, or if it's one of these, then something else, I guess, something like that. I just try to do something like that. So like if we'll get the row length, and just typing out like from memory, like just straight up like number of islands, and then we'll do like path for I in range, row length for j in range, column length. I think, would it make more sense to reverse it too and just go like, because I only need a border. So I just start with the borders and then just like trace it. It's like 5. So 5, 3, 1, ocean, 5, 4, 2, ocean. This would be 2, 4, 5. No, that's too complicated. I think just check everyone, I think. Matrix at I, matrix at j. Whoops, and then it's just if ij, and then we'll do like row column. We could pass in if it is true, like true, like an array of true and false, and then like at the very end, can I do that? I think it's fine. And then, okay, so then we'll say like, okay, matrix at row at column. We want to mark this as seen, so we're not touching it. And then we have like our directions, which is like 0, 1, like 1, 0, left, right, up, and down. And then like you can actually check too, and then just say like, I don't know if that's too much data. Pacific, Atlantic. Oh, and we want every index that can do it. So it would be like answer.append, like ij. So then we'll go kind of like this. And then we'll hit like true. I don't know. I hope this works. I think this is fine. It's not terrible. So if I is 0, then we'll flip it. No, I don't like it. I don't like it. I don't like it. So then we'll do this or this. So then this will work because if we're in the last row, then ATL is true and then pack is true. Yeah, so then that works. And I think we can just return like if pack and ATL, like we just return true. Or we return like the little array, which is like true, true. Yeah, I think this is fine. So that'll handle that. And then we can just do our directions, loops, so like for direction, or like for X and Y. Yeah, whatever, for direction and directions. Then we'll do like row equals row plus direction. And we can't do row because that'll mess it up. SVN row is equal to row plus direction. And then we'll just like do track code like if. So we're equal to n row, which is less than row length, and 0, and column less than column length. And then we do the other and to like hold this off. And on the bottom of legibility, and then we just say like, okay, is the matrix at n row in column less than the previous one? So then we'll also have like the previous value. Start with 1, then we'll say, okay, is 1. Yeah, the previous value would be temp, right? It's less than or equal to temp, so like 4 here, I think passes because we do 5, 3, 1, then we're done. We do 5, 5, 4. No, this one's 4, 3, 4, 4. Okay, let me read it. Rainwater can flow into neighboring cells if the neighboring cell's height is less than or equal to. It can flow if the height is less than or equal to. So we do if the height is less than or we go to the currents. I guess this one would be the current, and then we're doing the new one. Yeah, so I think this is fine. And then we just have to check it. So we do it again, like the DFS. We don't need the previous thing here. We just DFS with the new row and the new column. And we can even check like if, or better yet, like val. Let's go to that. If val at 0 and val at 1, and just like return true. Because I don't think we need to check anymore. I think we're just good. And then I guess we'll just return val, but we want to know what it connects to, and I think its connection is, this will get overwritten. So I might just better just return pack ATL. And then like pack equals or equals pack or so we kind of always just set it to here. And I think that's fine. I think that works. We can see what's happening. Matrix not defined. Oh, it's height, not matrix. So that's cool. We cut this, clip this one out. I think this is fine. I don't know, should I, if I mark it a scene, I want it to be like, maybe like 1,000 or something, but. Put this back. And honestly, this one could probably be like this, if pack and ATL. Like that. Yeah, I cannot do it for string. Could do math.env then, so it'll like never flow to it because it's infinity. We just do like answer is equal to this, and chill. And I think we're infinite looping. No, just nothing hit. Oh man, that's annoying. Oh, because I didn't return anything. Oh my god, it did it for everything. So this is the same one where I shouldn't do this, and I should not do this. And I should only do that if both parts are, so like it should be like pack ETL, or like PA is equal to DFS, like this. If P and A, like then we do it. And this one should be what, true, true? Okay, almost, but not quite. We have a 3-4 here. 0, 1, 2, 3. And saying the 5 because 5 goes to 4. Oh, I think I messed this one up though. I said 4 is one of the ones that goes twice. Because 4 is here in this length one. So I think I just need to fix this logic. So that would be something like, there's only 2 points here, really here, that overlap both. And maybe you just do like an if statement for that. So it could be something like if row is equal to 0, -1. Then we'll do like ATL and pack is equal to true. Or do you do like equals? Like that in Python. And then like or. So only 2 cases. We flip it to where the column is 0 and then the row is the other one. Something like that. So then we'll do only for these, this one and this one. But then we still have all of these. So like if, for the rest of these, if the row is 0, if the row is 0, then all of these flip positions. All these flip Pacific. All these 0, all of them flip Pacific. I thought this one would, really thought this one would work. Maybe it does work and I actually just messed this up. I don't know. Zero, 1, 2, 3, 4. 0, 1, 2, 3. 0, 1, 2, 3, 4. It's this 5. It's this 5. I don't know what it is. Okay, no way. If row is equal to 5 or 4 and column is equal to 4. I just want to test, do some testing. False, true. Okay, so we're saying that the Atlanta is true. That's good. That's good. And then we go through the directions and we're like, oh, well, 5. And actually what I want is, I want to know what the temp is. Okay, it is 5, yeah. So we're gonna go here, 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 but then we're still in Atlantic. What's interesting, pack, Atlanta. Atlanta's always the second one. So I did that right, I didn't flip them. Okay, just fine. Everything's good so far, and then we go to here. which is that apparently one of these isn't. Only goes once. That's weird because I thought it would have hit this one too. Okay, what if I print the matrix, like the heights? It's gonna be like something like maybe off by 1 or something, like something super weird. I feel like, I don't even know what this looks like as a graph. I have not a clue. So we're here and then we go to 1. Bro, I'm not seeing it. I am not seeing it. Like maybe through here, but like it shouldn't even be triggering there. The only reason it should ever say Lana is in this condition or this condition, or if row is 0 or column is 0. And none of that ever happens. For some reason we get true. I guess it'd be useful to know what conditions are doing this. So if row is 3 and then that one is 3 and then what is like the new row, new column that's like causing that? Five, 2, 2, 3. So it'll be at 2 or 0, 1, 2. Zero, 1, 2. Oh man, it's here. That's it. It's the stupid thing. Oh my god. No, just hard typo that. Now we have another bug where we're missing a result. So we have 2, 2, but we're missing 1, 4. So like 0, 1, 0, 1, 2, 3, 4. So 4 should be. And why? Because it transfers to 4 and then goes to 3. And it never did that. Oh my god. This is so ridiculous. It seems to be the case it's not going there, and it could be because it's marked as seen. But that's why I have this iterating over everything. So I do here, I check this, and then I would go here, I would check this one. Right, and it would work. And I would go here, and it would also work because it would call it there. This is so stupid. I guess I could. I don't know how. No, I think it's just too impossible to actually do anything for this. I could go through it like logically. I guess I haven't done that. So like it would be like we're going we're check 2, check 3, check 4, check 5. And then we're like, okay, well we're at 5. 5 is the first one. And we're just like, oh well, you're the special case, so you're true. And then we go down and we keep going 1, 3, and we're like, oh well 1, 3. Okay. Like you don't get anything special. 1, 3 does not. Then we go through all the directions and directions. So we're going like up, left and right. And then we compare. In row, we compare this one. And then while it's less than, and then we're constantly adjusting it. So 3 Pacific, which it'll reach eventually. And actually what I can do is I can print pack ATL, and then I can print like the heights. Then I can print the temp. Okay, so go through with this. We're at row 0, 1, 0, 1. What I care about is 1, 3. Okay, I think I'm just gonna have to look at. I spent too much time on this, unfortunately. I don't know what bug I added, but unfortunate. Oh God, I hate all like the solutions for this too, though. How is this not a hard problem? I don't think this problem is that hard. The solution seems like pretty straightforward. It's just that it's very technical. Like there's very, 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 very technical. Wow. Elegant. Elegant solutions. And I can't even understand, not even fathom. I have to add printing to every step. So like, what happens when we're outside? Did you say before you watch he's back? Because he's down to one job. That's really funny. Yeah, I saw a couple of his stuff. And I'm in his Discord server, but I don't like look at it at all. But I've seen a couple of stuff. That's pretty funny. I'll have to look in and see what he's up to. Let me see. I was gonna try to pull it up. I think he always deletes all of his VODs though, so I think they're like hidden. Next stream will be Friday. Because he's down to it. This problem is actually really popular. Yeah, I mean, this one's like, it seems like that same like pattern. I mean, actually, like literally my solution is just like the same number of islands pattern, but like I'm just slightly tweaking it. And I have like some bug in my code. It's missing one case, which is this 4. Now that I think about it, I could just like flip this, but I don't think that, I think that actually destroys everything. I think that just destroys everything. But yeah, I guess I'll have to see on his Discord if he's streaming. I'll just like probably stop by. I don't know why he's like working multiple jobs. Oh my god. Let's see, like this. Bay Area mortgage is no joke. Those $1 million homes for like a little 50 square meter apartment. And the property taxes, yeah. I have a friend who lives in San Francisco. I hung out with him, and he probably mentioned like 5 times like property taxes just over like the 2 days I was hanging out with them. Honestly though, I feel like it's not that bad. Let me see. I think because I feel like if I look it up, it's like 3% or something. The problem is just like the $1 million homes. That's like the big problem. Yeah, that's the problem. Which is like 100K. So you need to make at least 200K. Yeah, or save just a lot of money. You'd have to save a lot of money. And also like it kind of like the problem it's not even 3%. It's like 0.07, I guess, which is like 1%. But I didn't look at the San Francisco though. But the problem is just the houses are super expensive. So like you have to put down like a good amount of money. 1 million gets you a shack in the hood in Oakland. I remember Simon said that like Domino's or something like just would not deliver like pizzas past like 7 p.m. like in his Oakland apartment. In-N-Out just closed their Oakland store, bro. Yeah, the U.S. is wild. That was like the biggest shock, like for me. Like it's kind of like a reverse culture shock. Is like going to San Francisco and Oakland, and New York City, and just like seeing crazy homeless people. There is no shot in anywhere in the world like is it as crazy as it is in those cities. I've never seen like just such like aggressiveness from homeless people. It's the airport, the area around the danger is so dangerous. It's where people smash cars and steal luggage. Yeah, it's so crazy. That's like, and that has to be like that's the least. That's the thing I'm least looking forward to. Doing when I go back. But like I think it's fine. Like I think you just like stay inside your house and then just like only go to like the rich areas, I guess. But like if you go to I don't know if you've been to New York City, but if you go there on the metro, like there is insane stuff. Um like just people yelling for no reason on the metro. If you're single, dude, it's great. You can just rent a room for like 1,200. Really? For 1,200? Oh, rent a room. I think you mean a room. Okay, I can see that for a room. Yeah, but everybody's like talks about like that places like Colombia, Mexico are dangerous, which they are. But like you just have to be like a little bit careful. But like it's it's kind of crazy how like you can just like sit on a metro and someone's just like yelling, or occasionally like punching you. I was in Oakland for a thing for Easy Post, and I was in Oakland for a thing for Easy Post, and I saw like a homeless person just like hit my coworker, and then like a day after that, like a day after that, people would say like, oh, I heard like some homeless person just yelling in the middle of the night and I couldn't sleep. I was like, okay, nice. And then I got back from an event at at night, and a homeless person like I was like with three of my coworkers walking into our hotel, and there's like a homeless person like right next to the hotel, and someone called me like the N word. Like she was like, I don't even know if I'm allowed to say the N word on Twitch though, but she was like, get out of here, like N word. I was like, bro, like hard ER, never in my life. Um, it's just yeah, it's just so crazy. But let me see, what'd you say? The tourists are getting murdered left and right. Yeah, it's just like mentally ill. Like the poverty in like Colombia just is never that extreme, or in anywhere in the world, because it's like it's just like they're just poor. Yeah, yeah, we just throw money to sweep it under the rug. Yeah. Yeah, I think yeah, but you have to be careful in Colombia just with like, just um, not walking around with your cell phone. I think. And again, if you're like looking for like drugs or like girls, you have to be careful for sure. Even more careful than you would in the U.S. I don't do drugs though. Um, yeah, true. No, I actually have one. I have a fake Android phone. Not a fake one. I have like a secondary phone because I was like kind of nervous. So I was like, okay, let me get a dummy phone. That said, I don't like so I have like my iPhone, I have my iPhone, yeah, my Android. But I don't even take it out. I walk around with my iPhone because I don't like the Android. This is like $100 device. That said, I use this for mobile app development, so it kind of doubles as that. Scammers can see it. I just use the face recognition. But wait, what do they can't take anything from your, what do you mean your iPhone passcode? I didn't know you could reset your account. That you I feel like your phone password shouldn't be, oh well, unless you mean like you log into something while you're online and you're like typing in your password, like you log into like your bank account outside, or you know, log into your Apple like ID or something. Yeah, I could see that for sure. Yeah. If I'm interested. iPhone thief. The Wall Street Journal. Oh, nice. Getting the iPhone and passcode. Do this interview. Yeah, you have to teach people. That's kind of crazy too. He doesn't look like super like tech savvy. Like this guy looks like um he doesn't look like he's like the penetration tester for like Apple. Like he looked like, and he would know about this vulnerability. So I'm curious how he even found that. But yeah, I'll try to look at it. I think. Let me see. I wanted to figure out what this bug is though. Wait, outside 1.3, starting 1.3. Cool, chill. Then we go to 1.4, chill. And then we go to 2.4. Why don't we go here? Well, I'm gonna have to take a break soon. It's about lunchtime. About lunchtime on the East Coast. Oh my God, please. Please. Okay, let's go here. Where are we at? I think I already did this though. No, it's fine. Why isn't it going to here? If it goes here, then it should be. Or am I wrong? Oh, it's the LF. No, I screwed myself with the LF, I think. I think that was it. I did LF. What? No. One three. I can't spend all day on this stupid problem, but like, I was curious that like, why is when it's at 1.4, is it not just jumping to 0.4 so that I can get my trigger? Because it would be 4, you would iterate through all the directions, you would go up, you would go here. Oh my God, bro. I'm gonna just ask ChatGPT. Screw it. Do ChatGPT. I have a bug in my code. And then let's see what it says. What does ChatGPT say? I am not properly marking the cells as visited. I don't know if that's true. I don't believe that. Yeah, I think they just made this thing up. This is so stupid. I'm gonna do X and we'll see. I don't think this is the case though, but like if and height is 0 not equal to X and let's do that. Nope. Because I don't think that's the case. No, it's in row, in column. There's no way this works. So I just did this bad with that way? I don't think this, oh my god, it does work. It's saying that I'm marking it as visited wrong, but I don't think that's the case. So let me, I don't know. Oh, I return and then I never actually reach this. Oh man, that's the problem with my code, is that I'm returning and I'm not reaching it. Okay. I think this is kind of important to like set up. But yeah, this needs to happen. Yeah, that was it. Oh man, that sucks. I lost so much time off that because I wasn't marking it. Dang. Yeah, I don't think this problem is that hard though. Which is kind of, I think it's good, I guess. But like, if you don't understand like BFS, then yeah, this gets tough. But and then I should have been marking this. I like marking as opposed to using a set though, because it doesn't use any extra space. My screen froze. Yeah, I guess so. It did. Yeah, it did freeze. Yeah, I'm having like huge trouble with with my like docking station. So it's like just like random stuff just happens. It's like so stupid. Thanks. Thanks for the support. Yeah, you are definitely help keep the stream alive too. That's how you earn lunch. Yeah, I think that's that might be the crazy way. No lunch until you solve like X amount of problems. Wait, did I tell you about this like kind of crazy idea that I had about like Leetcode problems and like money? I'm gonna I feel like one of the biggest things that motivates me for I think doing Leetcode too, at least now, something that I think about is that I think that if you so everybody like I mean it's obvious that like every like Leetcode problem like when you do like a blind 75 or something like that, like you're gonna get a job that's paying you like 100K more or something like upwards, right? I feel like you can actually assign like a dollar amount to this, but like if you do like the grind like 169 or whatever, like blind 75, like if you do all of those problems, like I should say that each one of those problems is probably worth like like $1,000 basically. Every Leetcode problem that you do, like you're basically gaining like $1,000, or you're paying like towards like this debt to make that. Actually, I think that's like 100%. Like for me, like as I'm just thinking, like okay, well, if I want to make this amount, I have to do like like 100 problems. So like I'm basically paying myself. It's like, do I want to make like $1,000 today? Like even more than that. And like this is 100K scales, so I'm actually lowballing this. Um, assuming they're like, yeah, I don't know. Assuming they're the good problems, like it's just like I don't know. Like it's kind of weird. Most people probably won't care about it. But that motivates me because I'm just like, oh well, um, if I solve 5 problems a day, like I'm basically getting $5,000. Like I don't get the $5,000 now, but in the future, like yeah, I mean you get way more. I don't know. You'll get the senior engineer thing and you'll make like 300K a year or whatever. Okay. Uh, so this one I didn't mark it properly, and then this one nth node from the end of a list. I think this is the one where you like get like the kth node. It's like you're like skipping, so you like do like an iteration over it to do one pass. But, like the other non one pass is like pretty obvious too. But I think if you like jump like 3 times or something, this one I don't know. Anyways, okay, I'm gonna go eat something, and yeah, I'll stream again, I guess later. Yeah, thanks for watching, and raid somebody. Yeah, unfortunately I don't know any people who are streaming on a work day. If I were gonna raid somebody, it would be pirate, but like pirate's too big, so like that's nonsensical. I think it's actually nonsense. I feel like you should raid smaller people or people who are like the same as you. Are there any Becca codes every day? Who the heck is that? Let me see. Becca. Becca. Oh wow. Grind and Leetcode. Yeah, I was gonna say should raid someone who's actually doing Leetcode. Nice. Okay. Yeah, I'll raid. I don't know how to raid. I haven't done any Twitch stuff in a while. Let's see how to raid in Twitch. /raid username. /raid and then followed by the name of the channel you wish to raid. So it would be in my chat. /raid. /raid B Becca. Like that. Okay, cool. Sounds good. I'll follow him too after this. And yeah, all right, cool. Thanks. See ya until later. The target channel has disabled raids. Oh my god. I'm gonna find someone else who's leak coding though, but yeah. All right, see you, Chris. Okay, cool. So we're gonna raid 256 Hooligan. I don't know who this is, but they're in Russian. Everything's in Russian. But, yeah. All right. Good luck, 256 Hooligan, with the Leetcode. And yeah, it looks like you're not here, but see ya.